Okay. All I have is this. Wait a minute. There we go. Do you work? Yes. All right. If I have 4 pairs of congruent things, so I have these 2 triangles, A, B, C, D, E, F. Yes. So, do you all agree that I can't have, so guys, come back to me. Hello, everybody. Okay. I need 4 pairs of things that are congruent, but I need to end up with 2 triangles that are not similar, yes? Is this from the, let me double check and make sure where I am. Oh, this is from the congruent. Oh, even better. Okay. I want 4 pairs of things that are congruent, but I want the triangles themselves to not be congruent. Okay. Do you all agree that if I have, let me see, how does this? If I have every side is congruent to every side of the other triangle, are those 2 triangles congruent? Okay, so I want you really with me on this. I need 4 pairs of things. I can have a pair of sides, a pair of sides, a pair of sides, and a pair of angles. Yes? That'd be 4 pairs of things that are congruent. Why is that list automatically not match what they want? They want to end up with a non-congruent set of triangles, correct? Why does that list not end up with that? Side. So when you're doing this problem, keep in mind, if you pick certain pairs of things, they lead to it having to be congruent. Yes, certain groups of pairs, you with me? So you have to stay away from that. So I automatically know that I can't have all 3 sides as 3 of the 4 pairs of things. Is that cool? So therefore, it must be at least 1 angle in the mix. Yes, in fact, at least 2 angles if I want to have 4. So I'd have to have 2 sides. Yes, a pair of 2 sides and a pair of 2 angles. And the trick is, I don't want to give too much of this away, but it's the trick is it's got to do with the orientation of the triangles. So real quick, side angle side. Yes, that would be if that was true. If this side and this angle were the same between the 2 triangles, the 2 triangles would be congruent, yes? So I have to stay away from that. So for example, if there were 3 pairs of things, you could do side, angle, right? Okay. So if you do side, angle, that could still work if you don't have an angle between 2 sides. So let me see. So all I want to do then is, if I really want this to make sense, I always do. And I don't always do it well, but I'm trying. So if I have 2 triangles, these 2 pairs of sides are congruent. Which angle do I definitely not want to be congruent then? That one. So I don't want this to be congruent. So I'm going to put a little X. So then these angles could be congruent, and these angles could be congruent, yes? Now, the trick is, the way I've drawn it, I really want you to see it. The way I've drawn it kind of looks like they're congruent, just because of the way I drew it. But if I avoid that angle, then it could lead to 2 triangles that are not congruent, even though they have all this shit that's the same. Yes? Maybe? So one way to look at this is just know what leads to definite congruence and avoid it like the plague. Just try to get away from it. So with 4 pairs of things, it's doable. Right? Okay, so 5 pairs of things, I want you to think about it. If 5 pairs of things between 2 triangles are congruent, what the shit was 2 angles, 2 angles, Two sides, two sides, two sides, yes? So that would be 5 pairs of things. Doesn't that just leave off either I don't know about 2 of the sides or I don't know about 2 of the angles, alright? It only leaves one set of things, either 2 angles from each, one angle from each triangle or one side from each triangle. That's the last thing I don't know. Can you identify congruent parts and stay away from things like side angle side? You see what I mean? Are you cool with, I need you to see how. Okay. These 2 angles are congruent to each other, yes? These 2 here and these 2 here. And these 2 sides are congruent, these 2 sides are congruent. That could lead to non-congruent triangles. If I try to add in one more thing that's congruent, do you see how that kind of leads to a potential problem? Or, yeah. So I want to point you again. This is as much as I'm going to say, and I will point you again to number 15 in part A. If you look at that answer, it might give you some ideas. Okay. Yeah. Okay. You're welcome. Okay. Anything else from homework or general stuff? Okay. So real quick, let me check in with you guys. We're going to finish that handout from that we started last time. We haven't finished it yet. And then I'm going to let you guys play around with some structure, with compasses and so forth. So can you let me know right now, does anyone need a compass? Okay, I think I can handle that many. You guys get the special little compasses here. I got 3. I think I saw 3 hands, which is good. Sure. Who else? Melissa? And make sure your pencil is sharp. I have a pencil sharpener with me, actually, I think. By the way, I want to show it. Let me see. Do I have it? Yeah. There you go. My little pencil sharpener. I like it. I have a thing for Max for whatever reason. So all right, guys. So let's do this. Are there no more questions from homework stuff? Yes.
Do you have any more of the work patterns?
Oh yeah. I do. I think some of them got lost in the sauce, so let's see if I have 4, 5, 2. Yes. Yes.
Without lines or?
Lines is fine. Sorry. Yes. Oh, sure. 4, 5, 6, 2, 3. Okay. Did I leave myself? Yes. Okay. All right, guys. By the way, guys, we're getting very close to the end of things, the end of all things. No, the end of the semester. Yeah.
We have a final?
Yeah.
When is it?
I don't know. It's on the.
My friend's like, when's your final? I was like, he really hasn't said anything about it, so I couldn't tell you.
I told you on the first day.
But not recently.
No. So, on your homework sheet and on the syllabus, it's got the date of the final. What is it again? Is it June? June 2nd. Yeah. It's because of that holiday. We have the holiday on that Monday. That. Oh, by the way, is it you guys? Yes. I currently have a test. Is it you guys? Yes. On the 26th. Is that right? Is that you guys? Yes. Okay. Obviously, that's not going to work. You with me? Okay. All right. So let's not do that. I'm not going to bring you here on a holiday. Yeah, they won't even let you in. You'd have to drive over the grass to get around the barricaded, but
The teacher told me when.
no. So we're gonna have it on the 21st, I think, is the Wednesday before that. Still plenty of time. You guys with me? So that's my fault, and I own it. And I'm not good with numbers, so what do you want from me? So everybody write that down. I'll remember to. No, I don't want to say I'll remember. I'll try to remember to send out an email, but our, oh look, our next test will be on the 21st, yes? That's a Wednesday before the holiday. That gives us plenty of time, by the way. We have a decent amount of time just to live with some of the stuff we're about to do, which is great. That's why today I want to give you some time just to play around with stuff, because how often have you guys ever used a compass? It's fun. I don't use them very often either, so I had to play around with mine just to remember kind of how to hold it, what to do, so forth, yeah. Okay. And the final is on that last Monday, June 2nd. It would have been on, I can't remember now. No, we're good. We'll just put it there. So everybody else, does everybody else have this here? Okay. So let's look back at this guy. I'm looking at what I did last time. So we stopped at number 8. Can you guys remind me, what does it take for two triangles to be similar? What's one thing that somebody could tell you, and then you would know that two triangles are similar? Two angles are the same. I love it. Because if two angles are the same, then all three have to be, right? So we kind of started off with AAA, AAA. If all the angles are congruent between two triangles, then obviously the two triangles are similar. They definitely don't have to be congruent because their mouths could open wider. They got bigger sides, yes? But then we went, what the shit? I don't have to be told all three, because if they tell me two, then the last one's got to be the same two. Okay. And then we kind of went from there and we said, okay, what if they only give us one angle? What else do they have to tell us? And in that case, if they only give me one angle between two triangles is congruent, what else specifically do I need to know? Two sides that are where? On the sides of the angle they gave me, right? So it kind of defines the mouth. So to me, that's, I keep bringing up the idea of a mouth, because when I think about an angle, it kind of tells me how wide the mouth opens. And then it makes sense about the side fitting in at the end of its mouth, yes? So if they give me the angle and then the sides on either side of that angle, that's why it's called side, angle, side. Then there's only one stick that could fit here. Does that make sense? So this is the same length on both triangles, this is the same length on both triangles, and the angle between them, so the mouth opens the same amount, there's only one possible length that could fit there, which would then make the triangles congruent to each other. So that's really all we have to go on with similar triangles. If I do have similar triangles, then their sides are in ratio to each other, right? Their sides are multiples of each other, correct? Okay. So, the easiest way, if I'm given two triangles to tell if they're congruent, is if I know two angles are, similar, if I know two angles are congruent. The way they gave me number 8, they just gave me one angle to be congruent between the two, correct? But if you step back, I don't know what I was doing there. If you step back, I think one of you guys pointed out something really good. This is what I said to you guys. If you want to write a similarity statement, you want to set up the correspondence. So the way that they set up that similarity statement, what point A, B, or C in triangle ABC relates to point B in BDC? What do we mean then? If these two are similar, I should be able to rotate this and kind of like blow it up, and it should look like the other triangle, correct? So which vertex would line up with which other vertex? Say again? Yes, good. So vertex, the point A in ABC, would be in the same place as B if I rotated it and shrunk it down. Okay. What do both triangles have that are the same? What do both triangles share? Which angle do both triangles share? C, okay. Do you guys see how angle C is in both of the triangles we're talking about? And just to say this, do you guys see how there are 3 triangles up there, yes? One of them we don't care about at the moment, right? Could be a great triangle, I don't know, we just gotta ignore the guy. Which angle do both triangles we're talking about share? C. So isn't that angle congruent in both triangles? Because it's the same angle, correct? So do I have 2 angles that are congruent between the 2 triangles? In this triangle, the little dude, BDC, this angle is congruent to that angle in the other triangle, ABC. In BDC, this angle is congruent to this angle in ABC because of the same. So really quick, if they had been talking about the 2 internal triangles, these 2 here, you'll see problems that might talk about this triangle versus this triangle, then this side is congruent automatically because it's the same side in both. Does that make sense? If I was talking about those 2 triangles that are joined at BD, BD is in both freaking triangles, so you automatically have that that's congruent, yes? Okay. So in this case, I have an angle that is sitting in both triangles. So it's automatically congruent, right? So why can I say that these are similar then? Can somebody sum that up? Why can I say these are similar? What was it? First thing we said was the most basic way to tell 2 triangles are similar if all 3 angles are the same, congruent. Then we went, we don't need all 3. If you just tell me 2, I got the 3rd one. So we just need 2 angles are congruent, correct? And what is it that we know? 2 angles are congruent. Good. Okay, I love it. So many guys are like, we got it. So many guys are like, I don't know what. Which pretty much sums up the whole profession of teaching. Trying to teach somewhere in the middle there. Okay. And by the way, if you weren't here yesterday, I mean, I'll flash up here what we did. You know what I mean when I say yesterday. Sorry. What we did last time. Nope. Yep. Okay. So you can watch that video if you want to. So let's look here. This one's a little, so they tell us the triangles shown are similar. Can somebody, I talked about this situation specifically. If you rotate this sucker, then if these 2 are similar, can anyone tell me anything about line segment SU and line segment VW? They have to be parallel. So the whole idea there is like T is an angle, makes this angle. So if I chop it off at various points, I'm going to make a whole bunch of similar triangles. And of course it's because of the fact that they're parallel, you have all these corresponding angles are the same, and the whole idea of getting similar triangles is really hinging on the angles have to be the same. Okay. So let's not do every single one. Can somebody tell me what pairs of triangles are congruent here? I mean, they give us S and V, right? So angle V and angle TSU are congruent. One is really silly. What angle is just in both triangles? T. So angle T is congruent to angle T. That's crazy. And of course, the last one is angle TUS and angle W are congruent. So if they give me two triangles that are congruent. This one's kind of nice because it's easy to see what maps to what. S maps to V, U maps to W, and T maps to T. Do you guys understand what I mean when I say maps? It's kind of like they are the same, just kind of like extended. Okay. Now look at number 11. What's going on here? This came up last time. What kind of angles do I see there that would be automatically congruent? Vertex angles, kick ass. How do you remember the vertex angles? Because they make the freaking letter V, right? Okay. So vertex angles are just angles that are kind of created in the same way, so therefore they must be the same measure. So these two here are congruent. I also know these little symbols here mean that these are parallel to each other. If these two are parallel to each other, then this is a transversal, yeah? Remember this? So if I kind of, just to help myself out of it, if I kind of extend this, what's the same as this angle here? I'm going to call this angle A just because. Let me see if I can help you guys out. What's a nice way to do this? I don't know. Let me draw the situation again, but let me focus on just this. Do you guys see that? Just this line, yes? The problem with this is there's too many things happening. If I just look at this, what is the same as A? Which angle? I don't know how you can identify. Let me see. 1, 2, 3, 4, 5, 6, 7. Sure, just to be different. Which angle is the same as A? 2. Why 2? Yes, and what relates to 2 over here would be right here, yes? So these two angles here are the same. And why can I, is everybody kind of with me? You guys cool? So it's really nice when I have parallel lines involved in my problem because that leads to a lot of angles being congruent. You see that? And you can be nice to yourself. You can draw on top of the thing that I give you and just make it easier to see. You could put a little thing on the side. The problem was there was 2 transversals, so let me just focus on one of them. Why can I stop there and just say, yeah, they're similar? I know they told us they're similar, but I wanted to show you why. I got 2 angles that are congruent. Therefore, they're similar. Kick ass. Can somebody give me, now, I basically just answered the question, but can somebody name, well, it's, all right. What are 2 angles that are congruent? Say it again. I love it. So like angle PNQ is congruent to angle LNM. Is that cool? And then of course angle, what's this angle here? Well, it's freaking P, right? QPN is congruent to LMN, so forth. So this problem was the reverse. I give you 2 angles that are similar. Can you just tell me what parts are congruent? Which angles are congruent? Okay. So number 12, remind me what that little symbol means. Similar, kick ass. So triangle, well, this is a very silly question. I mean, how many triangles did they give us? Just 2. So I don't know if you're going to get it. What triangle is PQR similar to? The only other one yet. Okay. Kind of silly. Oh, but be careful. Now in this one, they really didn't make this tricky. But I need, when I do this, if they reorient one of the triangles, I have to make sure to put P goes to L, Q goes to M, R goes to N. You guys with me? So when you set up a similarity statement, you've got to make sure that your vertices kind of line up with what they go to. Okay. And then, did you guys do number 13? I can't remember if I gave you enough time to finish this. Since I know those are similar, what's really funny is, if you set up your similarity statement correctly, If I look at triangle LMN, what two letters in the same place as PQ? LM. I really just wanna make sure everybody sees that. It is really, really obvious once you see it. If you set up your similarity statement correctly, then to set up the correct ratio is easy. PQ, LM. QR, MN. RP, NL, kick ass. Okay. And then 15 is using which two of those? What's 20? QR. Now, of course, they're being a little evil. They took this and turned it upside down, yeah? So this is like, this one is saying QR, and what's 18 coming from in the other triangle? LN. So they just turned two things around, yes? So QR was to MN as LN was to RP. So what goes up top here? $15, good, because it's MN, that's what goes to QR. And what goes on the bottom here? X, kick ass. And you guys remember how to solve that, little dude? Yeah? I'm sorry. I just love the reactions when I ask certain questions. Well, really quickly, what could you do directly on number 15 to solve it algebraically? What do you do? Cross multiply, kick ass. And that is the thing that students try to do everywhere. Once you learn cross multiplication, you just try to do it every time you see a fraction. But this is the only place it works directly. There are really creative uses of it. But what else do you notice? What about 15 over 20? What could you do with that? Yeah, holy shit. So if you can, do, because then you got smaller numbers to multiply by, yeah? I know you got calculators, but still, it's nice to see smaller numbers. And real quick, what does this reduce to? 3/5. Is that cool if I do that? Just 3/5 there? All right, help me out. 3/4. I love you guys, okay. 1520 equals 18 over x. 3/4 equals 18 over x. Why do I not have to cross multiply now? Why do I not have to cross multiply now? You just see the answer. What do I multiply 3 by to get 18? 6. So what do I multiply the bottom by to keep the proportionality the same? 6. So what's x? 24. You guys with me? Alright, this is a really silly little reminder, but anytime you can reduce a fraction in the middle of a big ass thing of work, do it. You got smaller numbers to worry about, right? Unless you're trying to add things and you need like denominators. What about 17? Did we just figure that out, x? Yes, we did. That's why I chose 17. Look at that. Go past Jeff. Every now and again. Okay. So what's up with 18? We kind of saw a problem like this earlier, but how can you tell really quickly if 18 is similar or not? Yeah, I agree. It is not. Why not? Because, all right, there's a few different ways you could do it. What would this angle have to be here? What do these add up to be? 149, right? You with me? And if it was 150, you would need how much more for this guy? 30. It's 149, so you need 31. Right? So, real quick, if they give me two angles, they could give me one of the same and the other one. If they would have put a 31 there, do you see the shortcut would be this plus this is 180. If you don't see that, you can always just figure out the last angle and see if it's the same. Are you guys, is that cool? So this angle would be 31, that's 41, it's dead in the water. Poor little dude.
What about 19? What do these symbols here mean again? Parallel. So these two are parallel, these two are parallel. That's a trippy set of isosceles. Anybody watch Parks and Rec? I think about cones of dungeon. So they're asking me if they can be proved similar. So in some of these cases, we might not have enough information. What do I need to show for two triangles to be similar? And this one, actually looking at it, they've given me too much information. I don't need to know those are parallel, it's kind of dumb. Don't I know two angles in this one? So then I can figure out what it leaves over for this, yes? And what does it leave over for this guy? This would be 147, 33. Now, real quick, here's the trick. Here's where I'm being silly. Do you all agree that this is 33? Now I see what their point is. Do these two have to be the same as these two? Good, I like it. So we still have more work to do. I know that these two are parallel, yes? Which means that this is a transversal here, yes? Okay. So these two are parallel. This is a transversal, so if that's 33 there, let me see if I can kind of cover up enough. What else is 33? I don't know if that's enough for you guys. Maybe I should try to redraw this. There's V and W, yes? Here's the transversal coming through. And then here is P and R. If this is 33 here, what else is 33? We're almost there. We're almost there. What else is 30? Oh, I didn't give you a way to identify. I'm sorry. Let me put, in the middle, I'm going to put O. So for example, this angle here would be VOP. Do you see that? Okay. So what other angle is 33 degrees? VOR. I love it. And I apologize. You guys are sitting there like, I don't know how to answer you, Jeff.
That angle right there.
Okay.
Do you see that tree?
All right. Sorry. Where is that at in the picture? Let me put P where it really is. There's P. I kind of put it over there so I can identify things better. Where's this angle in the picture? It's right here, isn't it? You guys with me? Now, that's 75. That's 33. Can you figure out what this is? Angle RPQ. Can you figure out what RPQ is? We got that 33 down there. I need to figure out either one of those base angles in PQR. Does that make sense? If I could just figure out one of those dumb things, then I know everything. Look at me go. The little in-between dude is 33. This guy is 75. So what's this guy? What do they all three have to add up to be? 180. So if one's 33, one's 75, what's left over? 72. So are these similar? Are these similar? Totally. Kick ass. Thank you now. Okay. 23, the same kind of idea. This one is exceptionally silly. Can you guys see why this one is really silly? Do you already have one angle that's similar in those two triangles? And don't you kind of, the way that they were constructed, don't you already have another angle that's similar? Can anyone identify the two triangles, two angles, one from each triangle that are congruent? Sorry, I should say. Say again. Identify.
So therefore, what must be true? Those two are similar because of AA.
All right, I like it. Do you guys start to get a feel? If I give you a problem like this, the first thing, if I were you, if I were a student in this class, I would first look to see, can I see two angles are congruent? Because if I can, I am freaking done. Or if I see that an angle is different, then I'm done. You with me? Depending on the problem, I might not be able to do that, but maybe then I go, well shit, is it side angle side? Can I kind of see that there's one angle that's the same, and then two sides are equal multiples of each other? You with me? So I kind of focus on the angles first, because that's normally the easier way to go. Especially when you got these vertex angles that's just sitting there waiting for me. All right, so wait, did I skip a whole bunch? I did. This one, I'm not gonna, I don't know why I told you to do this one. Is this a situation we've been in already? Yes. And then, I know I didn't say 24, but why is 24 really silly quick? Do they already have an angle in common? And what is this angle here? This is right, so do they have two angles in common? Yes. So go away problem, you're too easy. Oh yeah, this guy. If ABCD is a trapezoid, which they did not have to say because they put that these are parallel, yes? If these two are also parallel, is it still a trapezoid? Good, no, I like it. Trapezoid is specifically only one pair of sides are parallel. And then they put all the information. This whole sentence is not required. I understand. They put it all right here, but it's okay. We can let them feel like they're telling us something. Triangle ABE. So this is where things get a little freaky, but not too bad. Can you immediately see a situation that's come up a few times related to triangle ABE? No? What other triangle does it immediately have a connection with? Yeah, CDE, right? I'm not being careful with my letter placement because I haven't figured that much, but I can identify the triangle. I'm talking about that lower triangle, CDE, because they have, what do they have? Vertex angles. So between these two triangles, I know that these are congruent here. So therefore, all I need to do, if I can, is to discover if it has either another triangle is congruent, or two sides have the same ratio. I really want to make this one. All right. Can you guys, like for example, can you guys see angle BDC? You guys see that angle BDC? That's in, or I can even just say EDC, so it's really clear it's in triangle EDC, right? So you guys see that? That's, Jeff, you can go this, you can do this, Jeff, you can do like this. This angle here. Can we figure out shit about that angle? From what I know up here? Can we figure out anything specific about this angle? You can? Okay, cool, do it. Neat. I don't know. If you guys know, you can do it. I have no idea. Did they tell us anything about any angle? No, we just know that whatever these angles are, they are congruent. I do not know the measure of any angle, and I can't use a protractor because this is normally not drawn to scale. I'm trying to take you down the road. What do you always look for? If they give you a problem like this, and they say, can you show two triangles are similar in this big ass thing? What's the first thing you look for? Can I get two angles that are congruent? Do you guys start to see what I'm saying? You cannot get that. I don't have enough information. Well, let's see. Those are parallel. I was kind of hoping that you couldn't. Pretending I can't. Can you see, between the sides here. Oh, I guess we have to, actually. They didn't give it the way I thought they were going to. Damn. So, I'm sorry. What I was going to do is I was going to try to set up ratios of sides, but I'm kind of missing exactly the sides I would need. All right, so now I have parallel lines. I have a transversal through here. So whatever this angle is here would have to be the same as that angle there. Is that cool? Okay, so then we have it. All right. I was kind of hoping it was a different kind of problem, but no. If they would have given me the value for y and the value for x, I could have then set up ratios and showed there are two pairs of sides at least that have the same ratio. That would have been side angle side, yes? Okay. I didn't need to, because now I have two angles there. So now I know triangle ABE is congruent to what? This is where you got to be really careful. Yeah, ABE is congruent to, you said CDE? All right, let's double check. So ABE, so this one's got to be in the middle. I like it. And I have to end up at this angle here. So CDE, beautiful. Okay. So then what kind of relationship can I create? What is 6? That's AE, right? Or let me say EA, that might be easier to look at. So EA is the same as EC. And what's EC from the picture? 15. 8 is AB, and AB is the same as CD. And what's CD from the picture? X. And then you could do a similar thing we did before. If you reduce that, it's 2/5. Multiply by 4, you get 20. You guys see that? Or you cross multiply and divide, whichever way you want to do. You guys start with me? Once you identify the similarity statement, if you're very careful with what letter kind of corresponds to what letter, it sets up for you all of the ratios you could set up. AB to CD, BE to DE, blah, 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 blah. So then what's X? Who's got, did I just say it? Did I just say it? So this reduces to 2/5. Multiply this by 4, so multiply this by 4 and you get 20. Kick ass. Or you can cross multiply. Okay. For the sake of our sanity, that would work the same way. Yes? So I don't hear any questions from this. This would work. In fact, can you guys, if you haven't done 36 and 38 yet, can you do it? Just do it real quick for me. Make me feel better. Did they get a compass for me borrowed that the tip of the pencil's not very sharp? If you got a compass from your kit, it should have like just a freaking lead. If you got a compass from me today, it's got a little pencil in there. Yeah, a little golf pencil. Yours looks good? Okay. You're like, it'll work, Jeff. Let me know. Do you guys see how the first part of 36 is kind of silly? We've already established that 6 and 15 go together. So therefore, this is 15 and 6 that go together. What does 10 correspond to? 1. Yes, good. So it'll be DE, and so that corresponds to BE. And again, you got the same
thing you could do. You could reduce that sucker to 15 over 6, reduce it. Or you could just cross multiply, it's up to you. If you cross, let's do this one different, because I've been doing the same thing. If I just cross multiply, I get 15y equals 60. And then to solve for y, I just do what? How do I solve for y? Yeah, kill the thing I don't want. Die. And what is 60 divided by 15? 4. Just think about 30 divided by 15 is 2. 60 is twice that, so 60 divided by 15 is 4. So we answered 36 and 38 key. All right, guys. All right. 46. They tell us that the segments in blue are somehow special. These segments here. And they tell me that, they're a little bit unclear here. Do they mean this whole thing is supposed to be y minus 20? I am not certain. Maybe that's what they're telling me. Not screw that. Don't worry about that. I'm not sure exactly what they mean there. Very quickly, I kind of want to just get to the part where we can try these compasses. This is out. If an acute angle, this is really straightforward. If an acute angle of the right triangle is congruent to an acute angle of another right triangle, is there any way the triangles could not be similar? The fact that they're both right triangles tells you they both have a 90-degree angle, and on top of that, they have another angle that's the same. So it's bam. It's the double A. So they are similar. True. What about 51? This one's almost interesting. What do you guys think? Any thoughts? You have a 50-50 shot, right? I don't know, maybe you can come up with a third option. True or false? Well, actually, I don't do true-false questions anymore because I used to always get a student write that down. This. And then I'd tell them, now this is a true story, and I had him come over to me and I'm like, can you tell me what this is? Like, well, what was the answer? It was true. It was true. No, yeah, get one. So, what do you guys think about 51? It's not tricky, but there is one little thing that might throw students off. What's your immediate gut reaction to that? Every equilateral triangle has what angles? What are the angles in an equilateral triangle? 60, 60, 60, right? Because they all have to be the same because their mouths open the same amount, they have the same size stick. Equilateral is the same thing as equiangular, yes? Can you guys imagine what's the one situation that might throw a student off? Something I don't think I've necessarily talked about directly. Couldn't two equilateral triangles be congruent? In what case would that be? Where they have the same sides, yes? Same side length? Officially then, do we consider congruent triangles to be similar triangles? Actually, I do think I said this. Because I told you that the scaling factor, if the two triangles are congruent, what's the scaling factor? 1. Okay, beautiful. So 51 is desperately, obviously false. What about 52?
That would be true, just because
Yeah, why? So they're telling you which one of these angles is the vertex angle.
it's
The top one.
Yeah.
And if it's isosceles, what's true about the base angles? They're the same, yes? They have to be the same to each other, not the same to 40, yes? So how many options are there for the size of the base angles? 1. If the two have to be the same on the bottom. 40 degrees leaves out how many degrees total for the rest of the angles? 140. So both those have to be what? 70. So every set of isosceles triangles with a 40-degree, like vertex angle at the top, they're similar automatically because everything's got to be the same. All the angles have to be the same. So that one is a little bit nifty. So, if you like ice hockey, great. I'm not gonna talk. What I want you guys to do. So everybody's got some kind of a compass at this point, yes? Does anyone need to borrow a ruler? You could use your protractor side. You with me? I love these. This is crazy. These are individually racked. Yeah, I know. I love it. Everybody else? Everybody else good? Okay. So,
Don't worry.
oh yeah, you can use your protractor. So what I want you to do, has everybody got a English teacher so they can teach me how to speak? Does everybody have a blank sheet of paper at least? Let's say 3.
3 sheets of paper?
Yes. And you might not need that much, but just leave it. First thing I want you guys to do is what I've espoused throughout both classes. What I really want you to do is create whatever you can. Go for it. And if you want to, I can like share it with everybody, your creation. Is it real? What do you think I'm doing this for? What do you think I'm doing this? Number one, I think we all need a freaking break. Just play around with this shit, yes? What else do you think? Well, we'll talk about that later. Go ahead and play around. If you don't feel like playing, I'm sorry. I don't know what to do. Just play around. Do create whatever you feel like. Get creative. Got to think creatively. Do you know what I'm talking about? No? Structured example with you of the types of things we're going to be getting into. So let me see. Did I leave myself a compass? No, I got a broken one. Shoot. Oh, here it is. Sorry, I got one. Wait, that has nothing in it. That's not useful. Oh, here we go. This one. Okay. You know, real quick, those of you that have the plastic ones. If you have the plastic ones, right? Some of you have, if you look at it, you have something that those of us with the steel ones don't have. I don't know if you can see it. There's a little scale here. Right? If you have the plastic one, do you have the little scale in centimeters? Now you guys are all like, I'm not going to pay attention to you, Jeff. No? Yes? No? There's a little scale here in centimeters, but this guy does not, as far as I can tell, it doesn't have that anywhere. It just has this little wheel in the middle. The scale in centimeters here is to set the radius that you want, which is a nice addition. Okay. So, everybody get a nice, clean sheet of paper. When we do what we're about to do, we're going to do several things like what we're about to do. I'll give you a couple examples. We're going to learn how to, given an angle, we're going to learn how to bisect it. What that means is, if I have a 90-degree angle, I'm going to cut it into two 45-degree angles without a protractor. Are you with me? Protractor, you go, it's 45. No. So back in the day, there were a lot of the mathematics we use today were built off of geometry. And nowadays, geometry is seen as this little side note, this little side process shape. But a lot of what we had to deal with, people were really interested in planetary bodies, the motion of planets. And they tried to calculate certain things, and a lot of it was these geometric observations, right? So if I watch a planet and it moves, I've effectively got this big triangle that I just made, yes? And I can tell the angle of its motion, then I can do stuff like figure out how far away that planet is if I have some more information. You guys are all with me? So a lot of early mathematics were built off of astronomy and geometry. And now those two are kind of like over here now, and the math is over here, but this is what got things started. So back in the day, before we had much of anything, we had a straight edge. So when we do these constructions, you have to pretend like there's no markings on this. You cannot use this as a ruler. You have to use this as a straight edge. You guys with me? So in reality, like a paint stirrer might be a better thing to use. It's just this piece of wood that's, you can just draw straight lines with it. So can everybody right now, just down the middle of your paper, or however you want, to be honest, draw like a line. Woohoo! Don't draw it too close to any edge. Are you with me? So I put mine like right in the middle of the paper. This looks like my paper is judging me with its eyes closed. What I want to do is I want to, without the use of a ruler or a protractor, only with a straight edge and a compass, I want to make the perpendicular bisector of this line. What that means is, not only do I want to make another line that is perfectly 90 degrees with this one, but I also wanted to cut this line in half. Are you guys with me? That sounds difficult. Yes? I love starting with this construction. So these are called constructions. We're going to construct these things using a straight edge and a compass. There. I turned you on there. So here's what I want you to do. Hopefully you haven't made your line too big. I might have made my line too big, damn it. Let's see if I did. You have to open your compass to be a little wider than half of your, yeah, I'm going to start over. Maybe everybody has to start over. Make in the middle of your paper maybe a line about that big. Yes? Now open your compass to be more than half the length. See there? So that's more than half the length of my line segment, yeah? I'm drawing all over it, damn it. It'll be okay, John. Is everybody with me? Not longer than the line itself necessarily, but just more than half as long. Okay. So I've got my compass opened up to a little more than half as long as the line segment. So put your sharp pointy dude on one end. This is very interesting to try to figure out how to show you what's going on. Either end, it doesn't matter. We're going to do both sides. And then draw part of a circle here. See if I did that far enough. Just barely. Okay, I lucked out. Then put your pointer dude on the other edge of your line segment and do the same thing here. Okay, we might have to do this again in case. So when you make that part of a circle, you kind of want to do maybe half a circle just to make sure. You guys see what I'm going to try to do now? You're like, I don't know what the hell you're doing. I'm going to connect the 2 points of intersection straight down. Yes? So now I take my straight edge and I connect straight down. And let's see how close I got. And this is by hand, so it's okay if it's not perfect. But that looks pretty dang good. That looks almost perfectly 90. That's awesome. Does everybody get that idea? Also, just to check, you can't use this to actually construct this. Oh, this is not the best, but this is just a bit more than 7, and this is just a bit more than 3.5. So that's pretty close to being straight down the middle of this. Yep. So we made a perpendicular bisector of that original line segment. Has anyone ever seen that kind of thing before? Where you use compass and straight edge to do this kind of thing? You have?
Yeah.
Okay. Did you do even more than just this one?
We just draw lines on the, for example, like this building without any
Oh, dude, all right, real quick. Talk to us a little bit about what you do. Is that your job?
Yeah.
Okay, beautiful.
So I do like framing and drywall and stuff, so I usually have to find 90 degrees angles when we do the frame. So for example, we have like a line, like, let's say they tell us that we have one wall here, and we need a parallel wall like to make a hallway.
Like a perpendicular
Yeah.
wall?
So we need to kind of like
Parallel.
find the center of that other wall, and then measure on this side and measure on this side, and then we just connect the three dots that would become like the 3 marks.
Gotcha.
So the line is like
So effectively, you're trying to make sure you find one distance and you make sure that distance is the same all the way down?
Yeah.
All right, so that's beautiful. And you were telling me earlier, tell everybody real quick about the construction of a circle.
So I just use a string and I tie it to a marker, and I find the center of where I want to draw the circle, and I just draw around.
Yeah, so he's got a string. He puts one end of the string in the center of the circling ones. The string is the radius, and he puts on this side, he puts a marker kind of like tied in the string. And you just keep the string taut and you draw, that's the radius obviously, right? Okay. Thank you. So, I mean, construction, people in construction, if they see this kind of thing, they've never seen it before, they're like, oh yeah, I do that shit. I do that shit. Now, not like we're doing right now, but effectively, you do this kind of thing all the time. You will need perfect right angles in construction very often, yes? And in fact, that leads to how to get perfect parallel lines. One of the constructions we will do is given a line and a point. Just to give you a little preview. And where we're going to go towards is if I give you a line and a point, we can draw the perfectly parallel line through that point. And what I'm going to be curious about is when we do it with our compass, I want to see how it matches up with what you guys actually do in practice on a bigger scale. So we're going to be doing, I can't remember how many of these constructions I wanted to pick out. I'd say about at least 6 constructions, maybe more. So that's one of them. This is one construction method, which is how to construct a 90-degree angle, and more than that, a perpendicular bisector. So it actually cuts this line in half. That's what's going to dominate our class for the rest of the time. Just to remind everybody, I moved the next test because it was at first put on a holiday, which is, you know, as a teacher, it's generally fantastic when you make mistakes. But when I was constructing the time, I wasn't keeping that in mind, whatever. So I moved it to the 21st, yes? Which means the 14th, which is what is today? Do I have the right dates in my head? Today is the what? 7th, that's right, 2 days after Cinco de Mayo, okay. Today's the 7th, so the 14th is gonna be review day. So next Monday, I'll have the practice test, and I'll have the answer key on that, okay. So Monday is gonna be when we do the rest of our constructions. Let me make sure I've got all my time frames right. Here, Jeff.